Hello and welcome to our lesson on dimensional analysis. Now that sounds kind of fancy, but it's really just a fancy name for converting, right? It's the process that we use to convert from one unit of measure to another, all right? So it's converting, the process of converting from one unit of measure to another. Now, within the metric system, it's technically the process again that you could use to convert, but in the metric system it's pretty simple because you're multiplying or dividing by a power of 10, and that just simply means you're moving the decimal to the left or the right. So the decimal moving is not something that requires a complicated process, and not that this process is complicated, but in our standard unit of measurement, most conversions require multiplying or dividing by a number that isn't a power of 10, and so it's not as simple as moving a decimal. And the dimensional analysis is just a way for us to organize the work because it could be complicated, depending on what kinds of conversions you have to make and how many what we call unit fractions you're going to have to use to convert. Okay, so within the metric system, again, most conversions require multiplying or dividing by a number that isn't a power of 10. And if it's not a power of 10, so if it's not divided by 10 or divided by 100 or multiplied by 10 or multiplied by 100 or 1,000 or whatever, then you can't just move a decimal. So converting from metric to standard or vice versa, metric to standard or standard to metric, would also require multiplying or dividing by a number that isn't a power of 10. So if you have to leave the metric system at all or convert when you're not in the metric system, then the multiplication and division isn't just a move of the decimal. So if you're going to use dimensional analysis to convert, again, metric to standard, standard to metric, or anything within the standard system, you're going to have to use unit fractions in order to make your conversion. And unit fractions are fractions where your numerator and denominator have equal amounts that are in different units. So equal amounts but in different units. So for example, a unit fraction could be 1 foot and 12 inches. Okay, 1 foot and 12 inches are definitely equal amounts, but one of the units is in feet and one of the units is in inches. Or maybe you have 365 days in 1 year. That would be a unit fraction. Two equivalent or equal amounts just in different units. Or maybe, I don't know, you could say that $1 has 4 quarters, okay? Whatever it is. If you have two equal amounts that are in different units, you could make a unit fraction out of those. And you can flip any of these too. So the first one I said was 1 foot and 12 inches. I could also say 12 inches is 1 foot. And depending on your situation, the first one might be helpful, or again, the second one could be helpful. It depends on your situation, okay? So those are examples of unit fractions, and those are what we're going to use to convert if we're in the standard system, or if we're going metric to standard or standard to metric. So if you're going to use a unit fraction to convert in this process that we call dimensional analysis, you're always going to start with the given amount. What amount are you given? What's the given measurement that you are starting with? And if it isn't a fraction, now this isn't required, but this is how I like to organize it, and I think it will be helpful for you as well. If it isn't already, make it a fraction. Make your given original initial measurement a fraction if it's not already, and we make a number by a fraction by putting it over 1. So for instance, if you started out with 15 inches as your given measurement and you're going to convert to something, start out by making 15 inches a fraction by putting it under 1. And then we're going to end up multiplying it by 1 or 2 or several fractions, depends, unit fractions, depends on what we got to convert to. So I like to put it in parentheses. And then what you're going to follow it by is a unit fraction. So you're going to end up multiply by a unit fraction. And what you want is a unit fraction that connects the units that you're trying to get rid of and the units that you want to convert to. So for example, let's say you wanted to go 15 inches to feet. Okay, what you're going to need then is the unit fraction that I have up here, or here, one of those I'll talk about in a minute. You want a unit fraction that relates the units that you want to get rid of and the units that you want to convert to. So I need a unit fraction that has inches and feet that relates those two. So inches and feet, we know there are 12 inches in 1 foot. The question is, do I use 12 inches in 1 foot like this? Or do I use 12 inches, oops, that's the same thing. Do I use 12 inches in 1 foot like this? And the answer is the way I have it in here right now. You want to get rid of the inches and end up with feet. So you need the inches to be on opposite sides of the fraction. If the units are on opposite sides of the fraction, then they will cancel. So you're going to make sure that the units that you want to get rid of are on opposite sides of your fraction when you set up your initial and your unit fraction. From there, you're going to multiply. Multiply straight across the top, multiply straight across the bottom. So in this case, 15 times 1 would make 15, and then 1 times 12 would make 12, and then you're going to divide that result to get some decimal possibly, and the only units that are left will be feet. So that would be 1 and 3, so 1.4, and then feet. Okay? So don't worry, we're going to practice that process just a bit. I was trying to just give you a little sample. Okay? So you're multiplying straight across the top, straight across the bottom. You're going to divide that last fraction that you have left over, and then the only units remaining should be the desired units. Your desired units should all be all that's left at the end in terms of units. Okay? So let's try this. And this doesn't need to be circled anymore. So let's try. And the unit fractions, while I'm hoping that most of the ones you see here, or many of the ones you see here, you'll know, I'm not expecting that you have them memorized, and I don't have like a table to give you a cheat sheet or whatever. So if I'm asking you to do any conversions that require a unit fraction, I will list the unit fraction. So for example here, I'm going to ask you, number 1, to convert from inches to feet, and I'll tell you the unit fraction. Even though I'm hoping you know 1 foot is 12 inches, I'm going to give you the unit fraction. I just want you to be able to use it. Okay? So we're starting with 30 inches. That's the start. So I'm going to put 30 inches, and again I want to make it a fraction by putting a 1 under it. And then the unit fraction, since I want to convert to feet, I have to have a unit fraction that contains the same 2 units, inches and feet. And we have that here. Okay? So I want the same 2 units, so that's my unit fraction. So I'm going to multiply by my unit fraction. I just need to make sure that when I multiply it, the units I want to get rid of are opposite sides of the fraction. So I'm trying to get rid of inches, which means I'm going to put 12 inches here, and then the 1 foot here, so that again the inches cancel because they're on opposite sides of the fraction. So we're going to multiply straight across the top. 30 times 1 would be 30, and the only units there are feet. And then we're going to multiply straight across the bottom. 1 times 12 is 12. And you could really leave it like that, 30/12ths of a foot, you could say, or you can use your calculator and make this a decimal. So 30 divided by 12 is, come on, 12 is 2.72 repeating. So 2.72, I'm going to put the bar over because it repeats, and that would be feet. And there it is, 2.72 feet. Okay, not so bad, hopefully. Let's try again. So here we are starting with 26 ounces, and we want to convert it to pounds. 26 ounces to pounds. So 26 ounces is my start. OZ is the abbreviation for ounces. I'm going to make it a fraction by putting a 1 under it. So 26 ounces is my start, and I want to convert to pounds. So I'm going to multiply by a unit fraction that connects ounces and pounds, which this does. 1 pound is 16 ounces. So when I write my unit fraction in here, since I'm trying to get rid of ounces, the 16 ounces will go here, and the 1 pound, pound is abbreviated LB, goes here. And that way, again, the ounces are across from each other and they cancel. So multiplying straight across the top, 26 times 1 is 26, and the units would be pounds. And on the bottom, 1 times 16, no units left. 1 times 16 is 16. And now all we have left to do is divide. So 26 divided by 16 is 1.625. So 1.625 pounds. And that's that. Okay, not terrible. And some of you may not need this process. If you can go directly to the division, then knock yourself out. If you have no idea what I'm talking about, then just keep going with me here, okay? Now next is a little more complicated because the initial or the original given measurement is 60 miles per hour. So we want to convert 60 miles per hour to feet per minute. Now 60 miles per hour already has 2 units, so we're going to write it like this: 60 miles per 1 hour. So that word per is like your fraction bar. 60 miles in 1 hour. All right, it's already a fraction. So that is what we're starting with. That is what we're given. Now we're going to need to convert to feet per minute, which means we have to do 2 changes. I have to go from miles to feet, and I have to go from hours to minutes. Okay, so feet, I'm going to take care of that first. Let's go from feet first, okay? I have to go from miles to feet is going to be one of 2 changes that I have to make. And my unit fraction for miles and feet says that 1 mile is equal to 5,280 feet. Okay, so I'm going to multiply by 1 mile is 5,280 feet. And I put the mile on the bottom because I want to get rid of miles. Okay? Now I gotta go again here. I have to get from hours to minutes. So from hours to minutes, okay, I have to use a fraction that connects hours and minutes. So I'm going to multiply by hours and minutes. Now what's going to go where? So hours on the start here is on the bottom, so I'm going to put my 1 hour on the top here and my 60 minutes on the bottom this time, because again, hours have to be across from each other to cancel. And now we should be good to go. I just need another color. Can I use okay, let's use black. So straight across the top, multiplying 60, 5,280, and 1. So 60 times 5,200, where'd my multiply go? Times 5,280 times 1, which, whatever, it's 316,800. 316,800. And notice the only units that are in the top of the fraction there left are feet. So that's feet. Over on the bottom, 1 times 1 times 60 is just going to be 60, and the only units remaining on the bottom are minutes. And so now we're just going to divide. What is that? 316,800 divided by 60 is going to be 5,280, and that's feet per minute. So feet per minute. And there it is. Okay, so we have to make 2 changes, and we use 2 unit fractions. All right, here's one for you to try. It's another one of these doubles. If you think you can do it, then feel free to pause the video and give it a shot. Otherwise, we can try this together. So 8 cups per day is our start. So I'm going to start with 8 cups per 1 day. 8 cups in 1 day. And I have to go from cups to pints, and then days to years. So we're converting to pints per year. So pints first. Cups to pints. Cups to pints, it says, excuse me, that 1 pint is equal to 2 cups. So 1 pint is going to go here, 2 cups is going to go here, again because these cups have to be opposite of each other to cancel. And now I want to go from days to years here, and there's 1 year is 365 days. I forgot to put this here. So we're going to go here. I have to do 365 days on the top and then 1 year on the bottom. Again, because I want to be able to get rid of days. Since days start on the bottom here, it's got to go on the top here for those units to cancel. So now we're going to multiply straight across the top. 8 times 1 times 365. 8 times 365 is 2,920. 2,920. And the only units left there are pints. And then on the bottom, multiplying straight across, 1 times 2 times 1 is going to be 2. And the only units left on the bottom are years. Okay, so now we just divide. What is 2,920 divided by 2? 1,460. 1,460, and that's pints per year. Pints per year. Okay, hopefully not terrible. And I'm not going to ask you to do more than 2 conversions, so that's probably about as complicated as it could be. Okay? All right, now the next few we're going to look at, those were all standard measurements, every measurement we saw there. Notice our unit fractions all had equal signs. These were exact unit fractions. And if we're going to go from a metric to a standard or a standard to a metric, then the conversions or the unit fractions won't be exact. They'll be approximates, like as close as we can get, okay? There aren't going to be exact unit fractions for example, cups to liters, because one's a standard measurement and one's a metric. There aren't exact unit fractions that can change those, but there are approximate amounts. So you're going to see here your squiggly equal, which just means 1 cup is about, it's pretty close to 0.24 liters. Okay, so for example, this works the same, by the way. It's just we're going from a standard to a metric measurement now. We're starting with 3.5 cups. So 3.5 cups. And I'm going to put that over 1 since it's not already a fraction. And I want to go to liters. And I know from my given unit fraction here that 1 cup is about 0.24 liters. And I put the cup on the bottom again so that those units will cancel. So we're going to multiply 3.5 by 0.24, and we get 0.84. So that's 0.84 liters. And then on the bottom, 1 times 1 is just 1. So this is just 0.084 liters. Not so bad. Okay? Now, on the next one, it says that we want to convert 58 ounces to liters. So 58 ounces is our start. 58 ounces. I'm going to put it over 1 to make it a fraction. And we were trying to go to liters, but I didn't get a unit fraction for liters. That's okay. Let's go ahead and use what we're given here. Let's go ounces to milliliters. If I multiply by 30 milliliters in 1 ounce, I can still get rid of my ounces. So ounces will cancel. Now what I'm going to have left is 58 times 30. 58 times 30 is 1,740. Was that right? Yes. Milliliters. Okay. Now, if it said to go to milliliters, we'd be fine, but it's liters is what we're asked for here. If I need liters, that's an easy conversion. That's a milliliter to liter. That's a move of the decimal, right? King Henry died by drinking chocolate milk. If I want to go from milliliters to the base liters, I got to move my decimal 1, 2, 3 times. So if I move my decimal 1, 2, 3 times, then this is really going to be 1.740 liters. So a move of the decimal if we have to convert within the metric system. Okay? Let's see. Next one. We have 150 pounds. So if you weighed 150 pounds, I'm going to put it over 1. How much would you weigh in kilograms? So we know that 1 pound is approximately 0.45 kilograms. So if we were to multiply straight across, Let me just move this up a smidge. Okay. If we were to multiply straight across the top, 150 pounds times 0.45, 67.5. And, oops, I forgot. My pounds cancel there. So the only units I'm left with would be the kilograms. And then on the bottom, 1 times 1 is 1 with no units left, so it's just 67.5 kilograms. Well, looking at this, I think I might like my weight a little better in the metric system than in our standard system. Okay. Next one, convert 32 hectares per hour to acres per day. So hectares is a similar measurement to acres, okay? So acres is something that we use to measure like big plots of land, right? It's more of an area measurement than a length measurement. So acres, I'm sure we're familiar with that. Again, parcels of land are measured in acreage. Hectares in the metric system does the same thing. So it measures area, okay, of space. So we're going to make the same types of conversions here, 2 conversions. If we're going to go from 32 hectares per hour to acres per day, then we're going to go from hectares to acres, and then we're going to have to go hours to days, okay? So one thing at a time. Let's start with this, what we're given, 32 hectares per hour. 32 hectares, which is HA, hectares per hour, so per, that's our fraction line, 1 hour. Okay. And first, let's go ahead and get from hectares to acres, okay? Here's what we know. We know that 0.4 of a hectare is in 1 acre. And I put those on the bottom, the hectares on the bottom, to cancel out the hectares that were here. And then we also got to go from hours to days, and 1 day is 24 hours. So I'm going to put 24 hours up here and 1 day here because I want my hours to be across from each other. So hours on the top, hours on the bottom, those cancel. Now we can multiply and divide and figure out our answer. So 32 times 1 times 24 on the top is going to give me 768. So 768, and the only units left up there are acres. And then on the bottom, 1 times 0.4 times 1 is going to be 0.4, and the only units there are days. And now we can divide those results. So 768 divided by 0.4 is 1,920. So 1,920, and that's acres per day. Acres per day. Okay, manageable. One for you to try if you want to give it a shot. Again, feel free to pause the video. This would be a good opportunity for you. Using something we actually already used. It says convert $3.75 per kilogram to dollars per pound. Now, $3.75 per kilogram is our start. So $3.75 per 1 kilogram is our start. That's what we're given. And then we have to convert to dollars per pound. Well, we actually don't have to convert the dollars. We're in dollars already, so all we have to do is go from kilograms to pounds. So just changing kilograms to pounds. Kilograms to pounds. We know that 1 pound is approximately 0.45 kilograms, so this time 0.45 kilograms goes here. 1 pound, 1 lb goes here, again, so that our kilograms will cancel. And multiplying straight across the top, let's get out of there. $3.75, 0.75 times 0.45 is 1.6875. So that's 1.6875. That's still dollars on the top. And then that's 1 times 1 is 1, and that is pound on the bottom. And so this is going to be dollar, we're going to round that to 69 cents. We always round to the hundredths place if it's money, and that's dollars per pound on the bottom that we have there. 169 per pound. So if you're paying $3.75 per kilogram for an item, then that's really $1.69 per pound for that item. All right, last one is a little bit of a strange one. We have to go from 570 cubic centimeters to cubic feet. A cubic measurement is a little different. So 570 cubic centimeters, what does that mean? So if we have 570 cubic centimeters, that means we have centimeters cubed. Okay, I'm going to put it over 1, just like I did before. Now, centimeters cubed really means, what does it mean to cube something? It means we have centimeters times centimeters times centimeters. Cubic centimeters would be a volume. That means like if you had to multiply a length and a width and a height, and this was in centimeters and this was in centimeters and this would be centimeters, then when you multiply all those, your units would be centimeters cubed. Okay, that's what centimeters cubed means. There's 3 of those. So if I have to convert to cubic feet, then I have to get rid of centimeters 3 times, if that makes sense, okay? So to convert to cubic feet, I'm going to use this unit fraction 3 times. So 1 foot is about 30 centimeters. 1 foot is about 30 centimeters. If I only multiply it 1 time, it's only going to cancel 1 of those centimeters. So I have to multiply it a second time. 1 foot is 30 centimeters, so that the centimeters a second centimeter can go away. And then I'm going to multiply it a third time. 1 foot is 30 centimeters. Again, so that I can get rid of the third centimeters. And what am I left with? I'm left with feet times feet times feet. Well, that's feet cubed, okay? That is feet cubed. So 570 times 1 times 1 times 1 is going to be 570 feet times feet times feet, okay? On the bottom, 1 times 30 times 30 times 30. So 30 to the third power is 27,000. It's 27,000. And no units left on the bottom. So what do I end up with? 570 divided by 27,000 is 0.02, and then the 1 repeats. So 0. Ow, that looks so weird. 0.02, and the 1 repeats, and that's feet cubed. Feet times feet times feet. Cubic feet. Okay? I know the last one was a little strange, but hopefully the process of using dimensional analysis, one, either looks familiar or at the end of this feels like it's something that is manageable for you. And you're not going to see anything in your practice that isn't any more complicated than what we've done here. And again, you don't have to know any of the unit fractions. I will provide you with whatever unit fractions you might need. Okay? So hopefully that's enough for you to get going. But as always, reach out if you need any extra help. All right, take care.